Okay, what we're going to talk about today is your procedure for factoring things that look like this. For example, let's give you guys an example. 3x squared plus x minus 4. Okay? And this is, I believe it's in some ways your last factoring recipe. Okay? In some ways it's the last factoring recipe. So, yesterday what we did was we factored things that look like this. Is that true? Yeah. There was a value here in front of my x squared term. And then I said to you guys yesterday, how do you handle that situation? What do? Don't you? Yeah, you factor out the greatest common factor. So when you go through that and you say, okay, let me factor out the greatest common factor. I go, okay, my greatest common factor is going to be with 3 and what number's here again? 1, good. And negative 4. What's the greatest common factor? 1. Is that 1? So what's my quotient going to be? With what the work I did yesterday, I said, oh, my quotient's going to be now 3x squared plus x minus 4 divided by 1. So the quotient becomes 3x squared plus x minus 4. Doing the work we did yesterday, here's my quotient. Here's my greatest common factor. It's 1. And then we said yesterday, what you do is you factor the quotient. And you look at this and you say, wait a minute. Does anybody notice something about this? The quotient is the same as the original question, but more importantly, this is not what? You do not have chicken what? Soup. This is not chicken soup. That's what you want to notice. Because chicken soup had what number in front of the x squared? Chicken soup had a 1 in front of the x squared. Is that true? So if you look in front of this x squared, what do you guys see that's in front of the x squared? Is there a number here? That's why I put this here. Ladies and gentlemen, that's not 9. That's the letter what? A. So in other words, A here is not the value 1 like it was, like it was for chicken soup. Okay, you guys see what I'm saying? So, because of that, we need another recipe. Okay? So we need another recipe. Here's your last recipe. I call that recipe what? Beef stew. Do you guys know why? Because it's a variation of what? Chicken soup. You say, what do you mean? Well, it's kind of similar, but yet it's still different, right? How's it different? Instead of chicken, you got beef. Don't you still boil it? Don't you still what? Put the vegetables in it? Okay. So it's very similar, but it's also different. So here's your first step. Here's your procedure. You guys are going to follow this procedure what? For the rest of your life. Or at least until you get really good with factoring, and then there's another way you could do it, which is by trial and error. But you have to get very good with factoring first, you know. So here's the story. I'm going to give you the procedure. What's my procedure again? Okay, I'm going to say this to you. Say this: determine the values of A and what? C. So in this example, what do you guys think we can actually do? I'm going to erase this. You guys have that in your notes here? You guys have that already? You okay? Yeah. You don't have it? Okay. Are you okay? Oh, okay, good. All right. So let's look at this. Isn't this actually what? A. What is this? This number here is 1. Isn't that B? That's C. Let me say this to you. Determine the values of A, B, and C. So you're going to tell me the value of A here is what? 3. The value of B here is 1. And the value of C is, what's the value of C? Negative 4. Never say that B is x. B is the value that's multiplied to the x variable. B is multiplied to x. So you can't say B is x because they're different letters. Is everybody okay with this? All right. Is that easy or is that hard? Okay. Step number 2. Determine a pair of numbers whose product is A times C, but whose sum is B. You go, what are you talking about? Well, what's A times C anyway? What's 3 times negative 4? It's negative 12. Everybody okay with that? That's the product. What's the value of B? Positive 1. Is that true? So what I'm saying is that I have to find a pair of numbers whose product is negative 12, but whose sum is the value of B. And again, B is the value of negative 1. So this has to be the what? The sum. So let me ask you guys a question. Does that phrase or does that part of the process look a little familiar? Yes, it does. Yeah, it was part of, in a way, chicken soup. Do you guys see what I'm saying? So you got to give me a pair of numbers whose product is negative 12, but whose sum is 1. Boy, that multiplication and addition, those two operations in algebra are vital. What two numbers multiplied together is negative 12, but when added is positive 1? Is it 4 and negative 3? What's 4 times negative 3? Negative 12. What's 4 plus negative 3? Is that positive 1? You guys okay with this? You guys found the numbers. Now, if this was chicken soup, you would be what? Done. This would be over. Is that true? This is not chicken soup, though. What is this? Beef stew. So you're not what? You're not done. Step number what? 3. Here's step 3. I call this the rewrite step. Rewrite the bx term using the pair of numbers found. In step number what? 2. Okay? And you go, wait a minute, what are you talking about? Well, look at this. Isn't it true that you have, what do you have here? Bless you. Isn't this 3x squared, okay? Plus what? 1x minus 4. This is what you have to factor. Where's the bx term? Right here. Is that true? This is what they're saying for you to do. You're going to rewrite this 1x using the pair of numbers 4 and negative 3 found in step number 2. These are the numbers. What do you think they mean by rewrite? What do you think that means? What do you guys think? What does that mean to rewrite? And using these numbers? Let me give you a hint. What's 4 plus negative 3? Is that 1? Do you see a 1 anywhere here with the bx term? What they really want you to do is write this as 4x plus a what? Negative 3x. In other words, what you really have now is 3x squared plus 4x. Do you guys know what addition of a negative is? What's addition of a negative? It's subtraction. What you did was you rewrote that 1x as 4x minus 3x. Do you guys notice if you're to combine like terms, what's 4x minus 3x? It's 1x. What I'm saying is this is equivalent to the same as what you're seeing here. They're equivalent. They're the same. They're the same equation. You say, why are they the same? Melissa, you know why they're the same? Because what's 4x minus 3x? It's 1x. You guys are practically done. You could go home and get the turkey ready now. No? Almost. You guys ready? Yes. What's the last step? Step number 4, and you're done. I'm going to say this. Factor by what? Grouping. If you factor by grouping, do you guys have 4 terms? Yeah, wasn't factor by grouping 4 terms? Notice this, I got what? 1, 2, 3, 4. 4 terms. So let me write this down. You get what? 3x squared plus 4x minus 3x minus 4. Factor by grouping. Group the first 2 terms and group the what? Last 2 terms. And factor by grouping, did you guys work on that homework? Are you sure? Or are you just going to wait till the night before? I know. You do it the night before. Well, if you do it to the night before, you got now what? 2 problems, not 1. You got to factor by grouping and you got to do beef stew. Because if you don't do factor by grouping, you're not completing what? Beef stew. You guys see what I'm saying? If you're a student, do you guys even have Thanksgiving? No.
I do.
If you're a student, what are you really doing? We're using that time to do some work. I know some of you guys have some weekend plans already. I know. It's the way it is. How do you factor by grouping? Remember this? Factor by grouping. Factor out the what? You factor out the greatest common factor. Did you do that homework? Now that's 3 things you have to worry about the night before the test. Factor out what? Factor out the greatest common factor. So if you didn't do either of these homeworks, factor out greatest common factor or factor by grouping, you're really going to have a problem with beef stew. You guys see what I'm saying? That's why I've done this for you. First taught you what the greatest common factor was. Then taught you how to factor out greatest common factor. Then factor by grouping. And then chicken soup. And now what? Beef stew. Because all of those processes were involved with your standard factoring procedure. Beef stew. So if you don't have those components in place, you don't have the big picture. And if you wait till the last minute, that is not a recipe for what? Success. That's a recipe for failure. If you shoot high and drop a little bit, you're still in a good place. If you shoot low and drop a little bit, what's the problem? You're not in a good place. So you're shooting low if you haven't done those things, because that's what's going to get you in the end. So let's recall. Do you guys remember? I'll do the details here in this one. Let's remember, how do you factor out the greatest common factor? What is the greatest common factor of 3x squared and 4x? Okay. What's the greatest common factor now of 3x and 4? Well, you're going to say 1. In this procedure, what did you guys do in this procedure? What do you need if you're factoring out the greatest common factor? Don't you need the quotient? Yeah. So, okay, let's see. You got what? 3x squared plus 4x divided by x. We're finding the quotient. And then you need 3x minus 4 divided by 1. Here, you're finding its quotient. And so now you get what? 3x squared over x plus what? 4x over x. Let me do this. Can I erase this right here? Let's erase this. Because we need the board space. Then I'm going to say now, my quotient here, well, what is 3x squared divided by x? You had to do the homework for this as well. Oh my God, if you're waiting for the last weekend before a test to do all your homework. Ooh. 3x squared over x. What's that? Good. So my quotient here is 3x plus, cancel your x's, what do you have left? 3x plus 4 for the quotient. That's my quotient for the first problem. What's 3x minus 4 divided by 1? Well, let's take a look. What's 3x minus 4 divided by 1? What's anything divided by 1? And what's itself here? 3x minus 4? Okay. So let me write this all down. Okay, you guys okay with this process here? So let me write this down. What you're looking at really is this. 3x squared, okay, plus 4x minus 3x minus 4 really becomes, remember, if I factor out the greatest common factor from each term, or each pair of terms, because this is factored by grouping, what was that first greatest common factor? X. I get now what? X times the quotient, 3x plus 4. And then I get the number 1 for the greatest common factor times what? 3x minus 4. Because we said that's what it was. This is a 3x minus 4 here, if I divide. Here's my greatest common factor of 1. And what's the sign here? This is negative. Do you guys ever remember working on any greatest common factors where this is negative? Do you guys ever remember working on those? Because what comes next in the greatest common factor procedure? What comes next is the statement that it would write factor out what? The common term or the common factor. It's really the greatest common factor, by the way. Wait a minute. Wasn't this supposed to be what? The same? Wasn't that supposed to be the same? I think we talked about this. Is that right? It's not the same. This is 3x plus 4. This is 3x what? Minus 4. Now let's double check. What's negative 1 times 3x? Negative what? 3x. What's negative 1 times negative 4? It's not negative 4. That's positive 4. This says what? Negative 4. There's something we have to do. We have to do what? Change that sign. Will that help us? Let's see. Negative 1 times 3x still is negative 3x. What's negative 1 times positive 4? Is that negative 4? Now, some of you guys told me over here that the greatest common factor here was really what? Negative 1. Now, in a sense, that's not really true. But it is true. if you were to take out that negative now, okay? If you were to take out that negative now, that's going to make this a positive for a quotient. It doesn't matter to me if you want to take the negative out now or do this change of sign what? Later. It doesn't matter to me so long as you get it what? Right. Either approach. That's the bottom line. So some people want to take out that negative 1. Okay, go ahead. But then you get 3x plus 4. Isn't that really the common term anyway? What if you just left it that way? And then notice at the end, hey, that has to be positive. Is that okay too? Sure. Either way, you're factoring out the common term. You're done. You say, what do you mean I'm done? Yeah, factor by grouping. When you have that problem here, remember, when are you going to have this situation? Only when this is a subtraction sign right here between the two. This is where you're going to have to do what? Beware. This is where you have to be careful. When that's a subtraction, you got to beware. This is the situation that's going to happen. And so what's your final answer now? The common term is 3x plus 4. 3x plus 4 times what? X minus 1. And you are what? You did beef stew. All of this, well, I forget what I was saying. Anybody remember what I was saying? What was I saying? Oh, here's what I was saying. What I'm saying is that, do you guys agree that you need to know how to do what? Factor out the greatest common factor first, that process. And then, what else do you need to know? Factor by grouping. And then you should probably know about chicken soup, because you're finding pairs and numbers. And after you do that, shouldn't you know about how to do what? This beef stew? So in other words, all those pre-steps you have to know before you learn this main process. So if you are weak in any of those pre-steps, what would happen? You're not going to know this what beef stew. So that's to suggest to you what you guys have to do as a priority. Because to take intermediate algebra, they expect you guys to factor this in your what? Sleep. They may not even review factoring. I know I don't. Boy. Is that horrible? That's pretty bad, huh? All right, here we go. 4x squared plus 12x plus 5. I mean, you guys don't get nervous and scared about it. You guys know why you don't want to get nervous and scared? You scared? You know why? You know what you have to do. The scary part would be if you didn't know what you had to do. You see what I mean? Then you're really lost. You're not lost because you know what you have to do. All those steps. So if you know what you have to do, it's just now a matter of you what? Doing it. That's it. Do you guys notice? Isn't this a beef stew problem? Because you can't factor 4, 12, and 5. Greatest common factor is 1. So let's go through the process. This is A, right? B, this is C. So what is A times C? Isn't that 20? Okay, what is B going to be? 12. Is that true? I have to find two numbers whose product is 20, but whose sum is what? 12. What two numbers? Product is 20, but sum is 12. Give me two numbers.
2 and 10.
Is it 2 and 10? Is she right?
Yeah.
Let's see. 2 times 10 is 20. 2 plus 10 is what? 12. Okay. What do you do with those two numbers? This is not chicken soup. If it were chicken soup, you'd be done. All right. Isn't this really what? 4x squared now? This is rewrite. Plus 2x plus 10x. Because that 2 is positive, that 10 is positive, right? So just add your x terms. And then don't forget your plus 5. Isn't it true that 2x plus 10x is what? 12x. What comes next? Factor by grouping. Good. 1, 2. I got 4 terms. Factor by grouping. Okay, here we go. 4x squared and 2x. I know the greatest common factor. 2x. 10x and 5? 5. Is this plus? Yes, that's plus. Good. Look at this. What's now my quotient? Look at this. Don't I have to take these terms and divide it with my 2x? So you can almost do this mentally. If you have to write it down to find the quotient, you write it down. 4x squared and 2x, you get 2x plus 2x divided by 2x, 1. Now do the same here. 10x plus 5 divided by 5, 10x over 5, 2x. 5 over 5, 1. What comes next in this process? You factor out the common term. Do you guys happen to notice what's common? Yes. Now what do? Final answer is what? 2x plus 1 times. You guys are doing the beef stew recipe. That's beef stew. You guys okay with that? It's doable, like I said. You guys really, I can't emphasize this enough to you. (3x squared minus 5x minus 2). Yeah. Okay. Again, notice this happens to be beef stew. A, B, what? C. You okay with that? What's A times C? 3 times negative 2 is? Be careful, it's negative 6. If you make that mistake, is that going to be a problem? Absolutely. What's the value of B? Negative 5. Good. Product is negative 6. What's the sum? Negative 5. What two numbers multiplied together is negative 6, but when added is negative 5?
Negative 6 and 5.
Is that right? Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. You're right. What do you guys do next? Rewrite. 3x squared minus what? 6x plus 1x. It doesn't matter the order you use. It's going to work out. Here's another thing, ladies and gentlemen, just so I let you guys know. Don't forget that minus 2 here, right? Because this trinomial is equivalent to this 4-termomial, whatever you call that. 4 terms. It's negative 6x plus 1x, isn't that negative 5x? Here's what I'm saying to you. The moment you guys find the two numbers whose product is that negative 6, sum is negative 5, the moment you find two numbers, ladies and gentlemen, that means that this thing is guaranteed to be what? Factorable. It doesn't matter if you put 1 and negative 6x. It doesn't matter if you put a positive 1x, negative 6x. It is factorable. You're going to get the same answer. All right, next step. What do you call that? Factor by what? Grouping. Good. Here we go. 3x squared and 6x. 3x, greatest common factor. 1x and 2. 1x and 2. What's the greatest common factor? Good, 1. Is this plus? I don't have to be careful. What do I need now? Don't I need my quotients? 3x squared divided by 3x. Remember that? What's x? 6x divided by 3x. 2. What's the sign? What's x minus 2 divided by 1? What's anything divided by 1? Itself. Is this the same? Sure is. Factor out the common term. X minus 2, what's left? 3x plus what? 1. You're what? Done.
Can we do one that doesn't factor?
You want one that's not factorable? Okay, good. 6x squared minus 13x plus 4. Let's try this out. A, B, and C. A, what else? B, what else? C. What is A times C again? Be careful with this. 6 times positive 4 is? Positive 24. What's B? Okay. You guys with me on this?
So for the A and C, you just put them together now equal
Well,
24.
you multiply, yeah. Yeah, it's not putting together, it's just A times C. Okay? So I have to find two numbers now whose product is 24, but whose sum is negative 3.
Negative 13.
What is it?
Negative 3.
Oh, yeah, whose sum is negative 13. That's true. Give me a pair of numbers whose product is 24, whose sum is negative 13. Did you guys notice? Here's a hint. Could it be two positive numbers? Never. Positive times positive is positive, but positive plus positive is never negative. So it's not two positive numbers. Can I use positive and negative? No. Because positive times a negative gives you a negative, not positive. So it has to be two negative numbers, right? Negative times negative is positive, and negative plus negative is still negative. So it has to be two negative numbers. Let's do this systematically. Negative, instead of starting with 1, start with what? Negative 1. Negative 1 times negative 24. Isn't that positive 24? What's negative 1 plus negative 24? It's negative 25. That's not negative 13. Okay. What should I try next? What comes after 1? 2. Remember, we're going to do this systematically. Negative 2 times negative 12 is positive 24. But when I add these, don't I get what? Is that negative 14? What do I need? Is that good enough? No. All right, good. We're close, but what comes next? 3? All right, negative 3 times negative 8, right? They both have to be negative. Isn't that positive 24? But what's negative 3 plus negative 8? Negative 11. Is that negative 13? No. Okay. What else should we try? Negative 4 times negative 6. What's negative times a negative? It's positive. What's negative 4 plus negative 6? Negative 10? Okay. Is that negative 13? No. What comes next after 4? 5. No. 6. Okay. But we already had that 6, and it had to be negative. So if I put negative 6 times negative 4, yeah, that's positive 24. What do I know already? It's negative 10. What if I said, okay, what comes after 6? 7. No. 8. Negative 8 times negative 3, I know this already. I also know the sum already. The point I'm making is this. Once you get to a place where you're duplicating your work, aren't we duplicating our work? Why would you duplicate your work when you already have all the answers? You don't have to. Critical thinking skills you learn in mathematics. Critical thinking. Everybody says you don't need critical thinking. I say, oh my God, you need critical thinking. Yes. What do you say, Elisa? Close. If you can't find that pair, like we found the pair here. Remember I said, once you find the pair, that's what? Factorable. You can do it. There's a solution. If there is no what? If there is no pair, just like in the case of chicken soup, when there was no pair, what do we say? Not factorable. Good. And if you really want to impress your neighbors, what do we say not factorable really is?
Prime.
Prime. So if you're looking back at the book, you see not factorable, well, you know what that means. If you're looking back at the book, you see prime, well, you know what that means too.
I also have a manual that came with the algebra book and how to do factor. Step by step.
Does it do my steps here too?
Yeah.
It does something different? What does it say?
It's like shortcuts.
It's what's called trial and error. The problem with trial and error is that it's trial and error. And I actually, I've had more success, believe it or not, teaching people factoring by beef stew. Not by doing trial and error, but by doing the what? The recipe I gave you. So I have greater success. And either means more people are going to learn factoring by the procedure I show you than trial and error. I say there's nothing wrong with trial and error. That's actually how I learned, by the way. But you guys already know I had to take algebra 4 times or whatever. So it finally stuck, trial and error. We don't want you guys to take algebra 4 times. We only want you to do it once. So trial and error does have a benefit. When I factor personally, I'll do trial and error. But when I teach this, I teach the procedure because it gets you to be able to learn the process. And once you've learned the process, you'll go back and look at trial and error. You'll probably understand that better. Okay? So that's the deal. That's why I do what I do. But like I said, I've learned people do better by doing this process. Okay, so you wanted to see a non-factorable problem. Is that right? There's not factorable. Let's give you some more. Should we give you a hard one or an easy one?
Hard.
Let's make it really hard. How's that? 12x squared. (12x squared) minus 23x plus 10. Why do you guys want to see the hard ones all the time? A, what else? B and C, okay. What's the product of A and C? 120. Gosh, these algebra books, what's B? Negative what? 23. I wish they would have some mercy sometimes. So what do you guys think? What comes next? What pair of numbers' product is what? 120, whose sum is negative 23. Product and sum. I'm going to give you guys a big hint. Huh? How do you know they're both negatives, Crystal? The sum is negative, right? So notice this. If they both were positive, right, the product is, if they're both numbers are product's positive, the sum would be positive. So Crystal's right. They both have to be what? Negative. Because negative times negative is positive. Negative plus the negative is negative. Because if you owe 2 bills, you still what? Oh. So I'm going to have to go through this systematically. What would I do? 1 times, start with 1. Good. And then go, it's not this. Is that right? It never could be these. I know they're going to have to be both negative. And then 2 times what? 2 times 60. That's not going to work. 3 times what? 40. It's not going to work because this is negative 43. I'm close. What comes after 3? 4. 4 times what? 30. Is that going to work? No. Because that's negative 34 when I add them. Okay, what about 5? 5 times what? Does 5 work? 5 times what number is 120? Is it 45? 24? Is that true? Does that work? No. Okay, 6. 6 times what? Is that 6 times 20? They're both negative. Does that work? Boy, I guess we really have to know arithmetic, don't we? Shoot. 7 work? What about 8? 8 times 15. Does that work? Negative 8, negative 15?
Yes.
Yes, it does. So what I'm saying to you is, how you really do this is you go through this what? Didn't we talk about systematically? The systematic approach is in some ways the most efficient approach. Now, some people are arbitrary. If you're arbitrary but you're not good at the arithmetic, that can slow you down and that can make it impossible. If you're arbitrary but you're very good at arithmetic, some people are, then they can actually hit this what? Target. We're all different. What's the best way to learn this? How did I learn this? Systematic. That got me there. So notice that negative 8 plus negative 15. Isn't that negative 23? Okay. Is there real use of going through things systematically like that in your life, you think? Yeah. All right, here we go. What comes next? Let's write it here, just in case. Do you guys know? Isn't this really what? 12x squared. Now, what's that? Minus 8x minus 15x plus 10. I'm going to do this is my rewrite. Used to rewrite the bx term. Negative 8x minus 15x. So 12x squared, negative 8x, minus what? 15x, plus 10. 4 terms. What comes next? Factor by what? Grouping. How do you factor by grouping? Greatest common factor for both of them. They're going to be different. 12x squared, 8x. What's the greatest common factor? Is that 4x? 4x times a quotient. 15x and 10. What's the greatest common factor? Is that 5? Okay. Times a quotient. However you want to approach it. What's your quotient? 3x. That's minus 2. What's the quotient? 3x and 2. I'm going to put a plus and a minus. But I got to be careful, right? Why do I have to be careful? Isn't it true? If I divide both terms by 5 and that was plus, that makes that plus. But why do I have to be careful here? There's a negative, so double check. Negative 5 times 3x, negative 15x. Negative 5 times positive 2. That's negative what? 10. Is that true? It can't be negative 10. It has to be what? What was our fix? We're careful. What do you think? What's our fix? Make this what? Negative. Is it negative 5 times negative 2 positive 10? Isn't this the what? The same? Can't you now take the common term out? Yes. It's up to you. When you have this negative sign, you got to be cautious. I know, maybe you said, why don't we just say that the greatest common factor is a negative 5? Is that better?
Yeah.
Could you do it if you wanted to? Is that true?
Yes.
Okay. Isn't that common now? What do you guys have now? 3x minus 2 times what?
4x.
Do you guys know what we're talking about when we say the greatest common factor, negative 5? Shall I show some people so they can understand? Let's look at this. Let's focus on this. If you're here, and you say, what do you say? You want negative 5, but then you have to keep that as what? In other words, here's your quotient. You got negative 15x plus 10, and you divide by what? By the negative 5 here. In other words, she's keeping both of these terms as they are. She's including that negative sign. That's fine. But she's also saying that the greatest common factor is negative 5. So negative 15x over negative 5 plus 10 over negative 5. What's this? 3x. Isn't that what goes here? So you can write that as negative 5 again. You can write this as greatest common factor. She wants that to be negative. And this is her quotient. In the factoring out the quotient, or it's factoring out your greatest common factor term in your procedure here. But this is a negative sign, so she's factoring that negative out. Either approach, it's up to you. It doesn't matter to me, so long as you end up with what? Those two terms. Okay? Would you rather make the turkey this weekend or factor?
Turkey.
Would you rather make the tamales this weekend
Beef stew.
or the beef stew this weekend? You guys rather have chicken soup than beef stew? Both. Chicken Alfredo. Oh, no, you.
Hey, Mr. Judge,
Yeah.
have you ever heard that song, Chicken Noodle Soup?
Have you ever heard what?
Heard about that one song, Chicken Noodle Soup?
I've never heard of it. How does it go? Sing it.
I just know it goes chicken noodle soup, and the rest of the words. That's not how it goes.
That's not how it goes. Huh? Is that how it goes?
Yeah. I don't know words.
Let me double check if I'm okay with this. You guys distract me with that chicken soup song. I think it's right. Huh? Doing it in your head sometimes is not the best place. It's very easy to get your wires crossed. That's why I say to you guys, always write this what? You see how I write it down? Write it down because it keeps things straight for yourself. Let's see. Let's go through the process. Isn't that 3 times negative 6? And then what's b going to be? So the product is negative 18 and the sum is what? 7. Right? We need two numbers. If we find two numbers, it's factorable. If we can't find them, it's not factorable. What two numbers is product is negative 18, but whose sum is 7? What is it? What do you guys think? What number is it? Is it 9 and negative 2? What's 9 times negative 2? What's 9 plus negative 2? Is that 7? Rewrite step. 3x squared plus 9x minus 2x minus 6. 4 terms. Uh-oh, we better be what? Careful. Okay, I'll tell you how I'm careful. You know, it's not that big of a deal. Take out the greatest common factor here. It's going to be what? 3x, is that right? What's the greatest common factor of 2x and 6? Is it 3 or 2? So it'll be 2, depending on your approach. I just say 2. I don't even think of the sign at this point. 3x squared divided by 3x is what? 9x over 3x? That's plus 3. Do you guys know what you're going to have over here? The moment you found these numbers, right, Elisa? Because you found these numbers, what do we know? This thing is what? Factorable. I'm going to show you something that's even better. If I have x plus 3 here, would I even bother if I was okay with my, you know what I mean? If I was careful, I'm just going to put down an x plus 3. I'm going to cheat. I'm not even going to find my quotient. Because this is supposed to be what? The same. Look at that. How do you guys learn these little kind of things? Only by going through it yourself. So I cheat and put, oh, x plus 3. And then I go, oh, I had to be careful? Oh, you know what? Just put a negative. I was careful. Because negative 2 times x is negative 2x. Negative 2 times positive 3 is negative 6. I cheat down here, Lisa. Because I know it's supposed to be the same because I know it's factorable. If I can't find a pair of numbers, then you stop right there. You don't even get that far. And then now, you're done. Factor out the common term. You have x plus 3 times 3x minus 2. Here's your beef stew recipe. So let's go over a few more of these examples. We're going to go over our four-step beef stew process. Remember, we have to use beef stew. Why do we have to use beef stew for these? If you try to factor out the greatest common factor of 4, 12, and 5, what are you guys going to get? It's 1. So we can't factor out, a greatest common factor other than 1. So in other words, we're stuck with this a being 4. Okay, so identify your values of a, b, and c. So if you guys remember, your step 1 process was to multiply a with c. So 4 times 5 is what? What's the value? 20. B is 12. So we need two numbers multiplied together whose product is 20 and whose sum is what? 12. Does anybody know what the numbers are? Is it 10 and 2? Well, let's see. Remember, this is step 2, remember? So step 2, you guys tell me it's 10 and 2. Let's see. 10 times 2 is 20. 10 plus 2 is what? 12. So those are the numbers. Good. Okay, step number 3 now is the rewrite step. So you're going to rewrite your terms. 4x squared plus 10x plus 2x. These values are both positive. Plus your 5. Okay? Now, here's the deal. Step 4, factor by what? Factor by grouping again. So on step 4, you're going to have to take out the greatest common factor of 4x squared and 10x. What's your greatest common factor? What is it? Is it 2x? What's the quotient going to be? 2x plus what? 5. What's your greatest common factor of 2x and 5? It's 1. Remember, this is plus, so you can put your plus 1 times, what's the quotient? 2x plus 5 divided by 1? 2x plus 5. Remember, like I said, this here is your key. Once you have those numbers, it's guaranteed that these are going to be what? The same. So we're not done with step 4, factor by grouping, but I want to point out that you're going to have the same thing here. So now that you have the common 2x plus 5, you guys are done. 2x plus 5 times what? 2x plus 1. There you go. Here's your beef what? This is your beef stew. Okay, anybody have any questions on the beef stew process? Yes?
Does it matter if you put 2 in the front and then 10?
Okay, good. Should we put, do I have to put 10x first? 10x plus 2x, or can we put 2x plus 10x? What do you guys think? It doesn't matter. If you put 2x plus 10x, you know what you're going to end up with in the end? These same two factors. You might write down 2x plus 1 and then 2x plus 5, but Once you found the key values, it's factorable, and you're going to end up with these two terms if you factor by grouping correctly. Okay, so step 4 is factor by grouping. All right, so these are the 4 steps that you guys go through for every problem. Okay, anybody have any other questions on this one? Is that easy or is that hard? You got to go through and do what? Practice that procedure. So let's go through the procedure again. Notice again, we have to have a beef stew scenario here because the greatest common factor is 1. You can't use chicken soup here. That value of A is 15. It's not 1. So step number 1, the product of A and C, 15 times 3, isn't that 45? And then the sum B has to be negative what? 14. Step number 2, the key step. What two numbers multiplied together is a positive 45, but when added is negative what? 14. Well, you're going to say 9 and 5. But let's double check. Let's be careful, right? 9 times 5 is 45. 9 plus 5, though, is positive 14. It can't be positive 14. It has to be what? Negative. So, the only way, two numbers multiplied together is positive, but when added is negative, is if they're both what? Negative. Because a negative times a negative is positive, but a negative plus a negative is still negative. So the numbers have to be what? Negative 9 and negative 5. Okay, you guys okay with that? So be careful with that. Step number 3 then is 15x squared minus 9x minus what? 5x plus what? 3. This is your rewrite step. You're rewriting this bx term, negative 14x, with the values found in step 2. Okay, is it negative 9x minus 15x, negative 14x? So these statements are equivalent. So again, you go through the process. Step 4, factor by what? By grouping. You're going to be careful. There's a minus sign here, so we got to beware. So if we go through our process, we need the greatest common factor for factor by grouping of 15x squared to 9x. What is it? 3x. Good. What's your quotient? 5x minus 3. Is that true? Remember, what do? Take the 15x squared divided by 3x. I get 5x. Take the 9x divided by 3x. I get 3. There's subtraction really there. Now remember, this is the negative sign. So what did I say for you guys to do? Put that minus sign down. And then tell me what's the greatest common factor of 5x, ignore the sign, 5x and 3. 1. So put down your greatest common factor of a 1. Okay? You okay with that again? Now, what did we say has to happen here? Once we found those key values, and this is factorable, that this and this again have to be what? They're the same. These two factors will be the same. Now, what's there? Is that 5x minus 3? You get another what? 5x minus 3. Are they the same? Yeah.
A question, is there like a specific order that you would use for the 9 and the 5?
No.
It doesn't matter which one?
Order doesn't matter. Yeah, because you know this middle step when you add these terms, negative 9x plus a negative 15x, or a 5x, or you say negative 5x plus a negative 9x, the order in which you add these, it's still negative 14. Yeah, it doesn't have to be in order.
Yeah, but step 4 is still going to come out the same as well, right? You're not gonna...
Well, it might look different, but you're going to end up, after you complete factor by grouping, you're going to end up with these two same terms. Watch, take a look at this. How do we finish factor by grouping? Factor out the common term and write this as 3x minus 1. That's how we complete it. Now, if you wrote this in a different order, you're going to get actually probably 3x minus 1 times 5x minus 3. you're still going to end up with the exact same factors. Okay, you okay with this? Nice and what? Nice and easy. Here we go. Step 1. AC 3 times 1 is what? 3. B is 4. Step 2. Give me a pair of numbers. Multiply together. Positive 3 when added. Positive 4. What are the numbers? 3 and what? 1. Good. Step number 3. Your rewrite step. 3x squared, okay? Plus 3x plus 1x plus 1. Okay, 3x plus 1x is 4x. So here we go. Factor by what? By grouping. First 2, last 2. So greatest common factor of 3x squared and 3x is what? It's not 3x. Your quotient will be 3x squared divided by 3x. X. 3x divided by 3x. Plus 1. Greatest common factor of 1 and 1. Don't forget, this is what? Plus. What's the greatest common factor of 1x and 1? 1. Now, you guys found the key values, 3 and 1. This is factorable. So what's 1 going into x plus 1? Isn't that itself x plus 1? Or couldn't at this stage, we notice that if this is x plus 1, we know this is going to have to be what? The same, right? Last step, what's common? X plus 1, and you're left with 3x plus what? 1. And you're what? You're done. Okay, anybody have any questions on this last one here? Nope. Step 4, factor by grouping. Hopefully you guys did that over Thanksgiving. Factor by grouping like crazy, and you're now able to do this process. All you got to worry about today is that key step, really. All right, now what I'm going to do is these last 2, these last 3, I'm going to use this board space. So I'm going to erase this. Do you guys have this in your notes here? Okay, so let's erase these beef stew problems to use this portion of the board. Do you guys have that in your notes, the last one? Everybody okay with that? Okay, erasing? It's like I said, you go over this process over and over again. So we're going to look at 7x squared plus 15x plus 2. Okay, let's see. Step 1. AC, what are the values? A, B, C. So A times C is going to be what? 14, and what's B going to be? I'm sorry, yeah, B's 15, right? Okay. Step 2. What 2 numbers multiply together is positive 14, but when added is positive 15. 14 and 1. Okay, good. Step number 3, rewrite step. 7x squared plus 14x plus what? Plus 1x plus 2. Okay? So step number 3, or no, we're on 4 now, right? Step 4, factor by grouping. Group the first 2, group the last 2. So greatest common factor is 7x squared plus 14x. Is that 7x? What's your quotient going to be? x plus 2. Greatest common factor, 1x and 2. Plus 1. What's the quotient? Notice they're the same. Okay? This is always going to happen if you find these key what? Values. So, what's left? X plus 2, 7x plus 1, your factor by grouping strategy, and you're what? Done. Okay, you guys okay with this? Last, what do we got next? 6x squared plus 7x minus 3. Okay, let's go through our procedure here. Identify the values of A, B, and C. We got A, we got what? B, we got C. So what's A times C? AC, negative 18. What's B? 7. Step number 2. Give me a pair of numbers whose product is negative 18, but whose sum is what? 7. 9 and negative 2? Oh, you guys are good at this. Is that 9 and negative 2? Let's see. What's 9 times negative 2? Negative 18. Good. What's 9 plus negative 2? Positive 7. Good. Step number what? 3. Your rewrite step. 6x squared plus not 7x plus what? 9x. This is negative, so you're going to put negative what? 2x. You're rewriting the 7x term as with the values found here in step 2. So you get 9x minus 2x. Don't forget your minus 3. Step number what? 4 is called what? Factor by grouping. So, greatest common factor. 6x squared plus 9x. 3x. Good. What's the quotient? 2x plus 3. Good. And then I'm going to remind you, be what? Be careful. Beware. There is a minus sign here. Okay? You're going to have to be careful with that middle subtraction. Now let's double check. What's the greatest common factor of 2x and 3? 1. Put a 1 times. Now remember, did you find the two values that satisfied the product being negative 18 and sum being 7? That's the key. If you can find those values, this is factorable. So now, what's supposed to happen here? These two are supposed to, again, be what? The same. By the way, if you took 2x minus 3 and you divided by 1, wouldn't you get 2x minus what? 3? But why is that? First of all, that's not the same, isn't it? So if you just write down what you have here and keep that kind of makes a little sense. But double check. What's negative 1 times 2x? It is negative 2x. We're on the right track. But what's negative 1 times negative 3? What's negative times a negative? Isn't that positive? Is that positive 3 or negative 3? Negative. So what do you guys know? This has to be what? Positive. What's negative times a positive? Negative. Isn't that the same? So in other words, be careful when this is negative. Put your negative greatest common factor, and then make sure that this is the same. Okay, so you're almost done. You have what? 2x plus 3 times 3x minus what? 1. And you're done. Here we go. Let's go through that process for the last one. 10x squared minus 9x plus 2. Here we go. You guys ready to go through the process? How many examples did we do today? 10? Do some of you guys do less homework problems than I do examples? Bless you. Hopefully not. You guys just going to look over the examples the night before the test? Yeah, or right before class time? No, you guys want to go through this process. All right? You guys have to go through that process. A, B, and what? C. Step 1, A times C is 10 times 2 is what? 20. B is going to be what? Negative 9. Step number 2, what do you guys write down? Oh, we got to find the numbers. We got to find the pair. What pair of numbers multiplied together is positive 20 when added is negative 9? Negative what? Say negative 4 and negative 5. Do you want to go with that, or you want to switch the order? It's up to you. You want negative 5 and negative 4? Okay. Does it matter? No. Are these the pair? What's negative times negative? Is that positive 20? Negative 5 plus negative 4, is that negative 9? Okay, good. So, ladies and gentlemen, once you found those values, this thing is factorable. So, it's factorable. That's the key. That tells you that it's factorable. That means you're going to end up with the same here, okay? So, we got 10x squared minus 5x minus 4, the key, plus 2. Factor out your what? Greatest common factor. Boy, I'm going through all my markers. Boy, factoring just takes up all the ink. So let's take out. What's the greatest common factor of 10x squared and 5x? Huh? 10 and 5, what is it?
5x.
Good, it'll be 5x. What's the quotient? What's 10x squared divided by 5x? 2x. What's 5x over 5x? Don't forget, that's subtraction minus 1. Uh-oh. Be what? Careful. Is that right? What's the greatest common factor of 4x and 2? 2. Put down your what? 2. You guys with me on this? Now, 4x divided by 2 is really what? Isn't that 2x? 2 divided by 2 is really what? 1. You're finding the quotient. Are you going to put down plus here? No. What does it have to be? Has to be minus. Is that right? These have to be the what? The same. So that's a minus. Double check. Negative 2 times 2x, negative 4x. Negative 2 times negative 1, positive 2. They're the same. You're done. 2x minus 1, 5x minus what? 2. Okay, hold on. Let's absorb this and think about this. Whew, we're going to relax. What's your question? Question? Nope.
I have a question
Hold on, you guys. We have a question. What's the question?
about the assignment for this.
Oh, okay. We'll go over that. But do you have any questions on the process we just did? You guys okay with the process of factoring? This is beef stew, ladies and gentlemen. Okay. You guys did that. Hopefully you had some turkey and factoring. Let's go through the steps, okay? Remember, A, B, and C, you got what? Here's A, here's B, here's C. First step, if you guys remember, A times C, right? So AC, 2 times A, that's negative 6. B is what? positive 5. Let's go through our steps. Give me two numbers, multiply together. Is negative 6, but when added is positive 5.
Negative 1 and positive 6.
What is it?
Negative 1 and positive 6.
Is that true? Is it negative 1 and positive 6? Let's think. Negative 1 times 6, negative 6. Negative 1 plus 6, positive 5. Step 3, the rewrite step. You got 2x squared plus 5x minus what? 3. Oh, we didn't rewrite. We got to rewrite. Yeah, we rewrite with the numbers found here. So that's negative 1x plus 6x minus 3. Okay? The next step, factor by grouping. Group the first two, group the last two. Okay? Take out the greatest common factor. 2x squared and x, what's it going to be? X. What's your quotient? Do you guys know? I just look at this and say 2x squared divided by x, and then 1x divided by x, right? Numerator, denominator, numerator, denominator. I can just look now, right? So what are you guys going to get here? Is that 2x? What's x divided by x? Is that minus 1? You okay with this? Now we got 6x and 3. What's the greatest common factor? Is that 3? All right, and then what's 6x divided by 3? 2x, 3 divided by 3. 1, and this is minus. Do you guys know, again, once you found those values, this is the key. Once you get those values, these are guaranteed to be the what? They're going to be the same. So that's a common term, factor by grouping. It goes 2x minus 1 times what? X plus 3. And you're what? Done.
I had it backwards.
It's okay. If it's x plus 3, 2x minus 1, is that acceptable? Anybody have x plus 3 and 2x minus 1? Okay, if you did, that's okay. Just to remind you, x plus 3, 2x minus 1 is perfectly acceptable. All right? You guys okay with this one? Is that easy or hard? It's complicated. What did she say?
She said it's wrong.
What's wrong?
That the only science class you'll be teaching is the one from on Fridays.
Oh, is that right? I got to teach calculus at 7?
No, you're not.
Okay, good. Never teach calculus at 7:20 a.m.
She said that what happened was that they used last year's schedule.
Yeah.
Going off of it for this year.
Yeah. Okay. Thank you. AC, what's 3 times negative 5? Is that negative 15? And what's B going to be here? Negative 14, right? So we're looking for a pair of numbers. Multiply together is negative 15, add it's negative 14. Is it negative 1 and negative 14? Is that right? Is it? Well, negative 1, let's be careful. Let's try this out. Negative 1 and negative 15, be careful. What's negative times a negative? It's positive 15. That has to be negative. So automatically, I don't care about adding this. It doesn't satisfy the product. So what should it be? The only way you multiply two numbers and have it be negative is if one is negative, the other has to be positive. So which one do you want to be negative?
15.
Why? Well, is it true that 1 times negative 15 is negative 15? What about adding? What's 1 plus negative 15? Negative 14. Step number what? 3, rewrite. 3x squared plus 1x minus 15x minus what? 5. Okay, you okay with this? And then factor by grouping. What's your greatest common factor of 3x squared and x? X, good. Now what's your quotient? 3x plus 1. Good. You guys okay with that? Beautiful. Now, does anybody remember what's going to happen? Don't you have to be careful here? Isn't this what? Minus. Doesn't that have to be minus? So what's the greatest common factor of 15x and 5? 5. Good. Put your 5 down. Now, I'm going to ask you guys to think about this. Okay? Let's think about this. What do we want to think of? Did we find a pair of numbers that work? What does that always mean? It means that it's factorable, you're right, and that also means that these are going to be the what? The same. Because that's the only way it'll work with factor by grouping is if they're the same. Now, if you just ignore the signs and say, what's 15x divided by 5? That's going to be 3x, right? And then what's 5 divided by 5? That's going to be 1. The question is, what sign goes here? Don't look here. Look here. It has to be what? Positive sign. You go, but wait a minute here. I see a negative 5 up here. That's true. Because negative 5 times 3x is negative 15x. But negative 5 times positive 1 is negative what? 5. Is that true? So ladies and gentlemen, it is the what? Same. Because a negative times a positive is still what? Negative. So now you got the common term 3x plus 1 times an x minus 5. You have what? You factored. All right, you guys okay with this one? Okay, is that clearing out your Thanksgiving cobwebs? Yes. Okay, here we go. Step 1. What's that?
That's the same as the second one.
Is it?
Oh, no.
It's a little different. Be careful. Yeah, it looks the same. Yeah, they do. So we got what? A, we got B, we got C. So A times C, 3 times negative 15. What's that going to be? Is that negative 45? And then B has to be positive what? 4. Second step. Step number 2. Give me a pair of numbers. Multiply together. Is negative. That means one's positive, one's negative. It's the only way you can get a product being negative. Because if they're both negative, the product's positive. If they're both positive, the product's positive. So they have to be one positive, one negative, whose sum is positive 4.
Negative 5.
Is it 9 and negative 5? What's 9 times negative 5? Okay. What's 9 plus negative 5? Okay, good. So that's the key. This is going to be factorable. Okay? So good. Now I'm going to write down my third step. I have 3x squared plus my 9x. Use the numbers found here. Minus 5x. 9 is positive. 5 is negative. Minus 15. And then, ladies and gentlemen, factor by what? Factor by grouping. Step 4. Go through your process. Okay, so 3x squared and 9x. What is it, 3x? What's 3x squared divided by 3x? Is that x? What's 9x divided by 3x? Is that 3? Okay, you okay with this? And you got a 5x and a 15. Greatest common factor. Wow, okay, good. You're awake. You're considering the fact that that's negative, right? Okay, so you're aware. Remember, you had to beware of that negative sign in the middle? Put the negative sign. Now, all you do is find the greatest common factor of 5x and 15. Don't even think of the sign anymore. What's the greatest common factor of 5x and 15? 5. And then I just got through saying this is going to have to be what? The same. That has to be the same. Because this thing is factorable because we know we found the values. Right? It's factorable. Once you got step 2, it's going to be factorable. So double check, negative 5 times x is negative 5x. Negative 5 positive 3 is negative 15. You're good. All right, you guys okay with this? So final step, what is it going to be? X plus 3 times 3x minus 5. Beautiful. I got to fit all of this in this space here. Okay, anybody have any questions on these here that you're working with? You guys sure about that? All right, how about this? Let's do the last one. Did you guys finish the last one? Oh, you did? Good. A, B, and C. A, B, what? C. Okay, again, I want to point out to you guys that this is a beef stew scenario. Again, I'll remind you, why is it guaranteed to be beef stew? Like, why can't we just take out the greatest common factor of 6, 19, and 10, and then hopefully we have chicken soup? Do you guys know why? The greatest common factor of 6, 19, and 10 is 1. So, if you take out the 1 and divide this by 1 is itself. So the greatest common factor, trying to factor that out first, isn't going to help us in each one of these examples. That's why you have to know what? Beef stew. So here we go. A times C, my recipe. 6 times 10 is what? 60. My sum has to be 19. What two numbers multiplied together is positive 60 when added is positive 19?
15 and 14.
You guys know it already, 15 and 4?
Yeah.
Oh, man. Nice. Did you guys notice that this factoring recipe is based on arithmetic only? It's based on arithmetic and following a set of instructions. Boy. Okay, here we go. Step number 3, your rewrite. Here's the instruction for 3, right? 6x squared plus what? 15x plus 4x plus what? Plus 10. Okay, factor by grouping. So step number 4. Greatest common factor, 6x squared, 15x. What do you guys know? 3x, okay. What's the quotient? Is that 2x plus 5? You okay with that? Greatest common factor, 4x and 10. Is this plus? Sure is. We don't have to be careful, so put plus 2. And then what's the quotient? Is that the same? You guys notice this is the same? Okay, it's going to always be the same if you do the process correct once you found that pair. So this tells you that it's what? Factorable. That's the key. If you can't find the pair, what do you guys say again? Not factorable. Okay, what's your final step? 2x plus 5, good. And 3x plus what? You guys are done. Look at that. Beautiful.
So basically, that what's in the parentheses, that's going to be your answer?
What's in the box is the final answer. You factored out the common term by the greatest, taking the procedure of factor by grouping. That's the last step in factor by grouping. Yeah. Yes? Okay, say that again.
And then whatever that 3, 60 and 36.
Oh, plus 4x plus 15x? You're probably going to get, write it as 3x plus 2 times 2x plus what? The point is you're going to get the same two factors. Yeah, is that okay? Yes. It'll be okay. Okay, and again, if you switch these all that way, you're just going to get here x minus 5 and 3x plus 1 if you switch them. So ladies and gentlemen, this is a very big deal. You're pretty much almost there completely with your factoring career. Well, it just began. Anybody have any questions on these that we just did? Because I'm about to erase this rainbow. Gosh. All because it has to be in the same space here. We fit 4 examples. Anyway, here's what I want to say to you guys. Let me do this to you with all of these. Factoring, like I said, factoring is a pretty big deal, and you know, it's kind of, I don't know. You know, it separates a lot of people from being successful in math. Do you guys know, even in the calculus setting, that what really hurts students in calculus isn't, ironically, the calculus. It isn't the new material they study in that course. You would think, oh, it's calculus. It's what? Very difficult. Well, in a way, the hardest part of a course like calculus is just that you got to remember other things, like how to draw a line, you know, how to factor, how to solve an equation. You got to remember other topics in mathematics, and that's the hardest part for the students. It's not the new material, it's the old material. So it's not uncommon, or it does happen where you got students who's, if they're weak in algebra, being beginning algebra, intermediate algebra, then they're going to be weak in calculus. If they're strong in those algebra courses, they're going to be a strong calculus student. So long as they remember other topics like geometry and maybe trig. So if you want to be a calculus student, and there's nothing wrong with you wanting to be one, you should be one. You could be one, so long as you do what? Get strong in the algebras, and you're going to take the trig and geometry. If that's where you're at, you're going to be able to do calculus. No problem. Do you guys remember the story of Stand and Deliver, Mr. Jaime Escalante?
Yeah.
You know what he used to do? Because I was his former student. I know all his secrets.
What school did you go to? You went to Garfield?
No, I didn't go to Garfield. I went to Schur High School.
Oh.
How did you get his secret?
How did I get his secrets? Don't tell anybody. He taught at ELAC at night. And you know what I did? I went to school at night. I was a night student. Because I was working in the day. So I went to school at night. So I had Mr. Escalante for 2 years. Math 260, 261, 262, 263. I had him for 2 whole years. So I know all about everything he taught and everything he said and why. I can tell you. Isn't that amazing?
Was he a good teacher?
Was he a good teacher? What do you mean?
Was he a good teacher better than Berta?
Don't mention any names. If you didn't do your homework, you know what he'd do? He'd yell at you and throw you out of the room. Anybody here not do their homework?
I mean, I made it.
Oh, he would throw you out. He'd tell you to get out of here. Don't come back. And students used to leave crying because who wants to be yelled at? So you guys want to know, well, you want to know what his real secret was? It wasn't that he demonstrated mathematics any clearer than anyone else. He was average as a lecturer. But I've never met anyone better at motivating you to do your homework than him. He would lie, cheat, and steal to get you to do your homework. He would tell me I was going to be a millionaire. And so because I believed him, I did my homework. He would lie to you just to get you to do your homework. Do whatever it took, because he knew the secret was not anything he said to you, but what you do for yourself. That's the secret. If you follow up and do your homework like Crystal says, are you going to do well? You know the secret. You never even had Mr. Escalante. That was his secret. Nobody was better at motivating you to do your homework. But if you didn't do homework, he'd just throw you out. So he might have started with a class of like 50. He would end up with maybe 20 or 12. You know, by the standards of the school, he was a failure because he didn't end up with 40. You know what I mean? He ended up with maybe 12 or 20, so he'd be considered a failure. But the reason I'm bringing this up with algebra is because in high school, what he used to do for those high school students, he used to make them come an hour before school and stay an hour after school. Do you guys know that? What did he make them do for that hour? Algebra. So he'd work on those algebra skills with them an hour before and an hour after. Because in the class to do the calculus, that's all it was. 90% of calculus is past material. Algebra, trig, geometry. So he used to review with these kids every day before class and even what? After class, so they could be successful during class. And in that scenario, he would have like a group of, I don't know, 60 or whatever, move on to take calculus and do all this stuff. So it's just a different environment here that he had. He couldn't have us for an hour and an hour again every day. So he just, he would really scare people away at times, But that was his secret. If he could get you to do your homework, then he knew that's all it was. It wasn't really anything he did. It was everything you did. Isn't that amazing? What I find amazing is by the school standards, he could probably be considered a failure. And the irony is, the school every year applies for a grant in his name. They'll use his name. This is the Jaime Escalante, whatever. It's amazing. How everything really works and why really amazes me. Yeah, students would complain because he would yell at them and stuff. I never did. You know why? I was too afraid. I sat in front. I was afraid of him yelling at me, so I did my homework. I was like, man, I don't want him to yell at me. I'm doing my homework. And then after 2 years, you guys know something? After 2 years, somebody asked him and said, so who was the best math student in this 2 years? And I was like, yeah, I want to know who was the best, for 260, 260. You want to know who he said was the best? He pointed at me. It's like, me? Me? I was his best student in that 2-year period at night here. Me? Because I was afraid he'd yell at me, so I did my homework. Isn't that amazing? And then what did he say? He says, Daniel, you should major in math. You're good at it. I said, what? That's my name, by the way. Shh, don't tell anybody. He says, you should major in math. You're good. I said, but that's for smart people. That's not for me. Those are for people who are smart, majoring in math. So if he didn't tell me to do it, I would have never did it.
So you majored in math?
Yeah. I even went to graduate school in mathematics. That's a whole other story.
Is it hard when you go to graduate school to do mathematics?
Is it hard?
Yeah.
It's everything I'm telling you guys to do, that's what you do. If you do that and you focus on that, yes, you'll be okay. But not everybody does. Do you guys know that? Not everybody is gonna work every day at something. Not everybody does. They're just not wound that way. Could you imagine every moment of your life you worked at perfecting what you do? Would you be any good at that every second of your life, you guys think? If you perfected what you did, how good would you be? Do you guys think Kobe takes a break from basketball? He doesn't take a break from basketball. He does it all the time. You know how good that guy really is? How old he is? He should be breaking down. But because he does it all the time, perfects what he does, he doesn't even care about money. He just cares about basketball. There are people who are like that. If you do that, you're going to get better at what you do. Doesn't matter what it is.
Same thing with Jordan. When he knew that he was old, he knew he couldn't do the same things he used to do. So instead, he would pass the ball to the teammates, and he would be more of a supporting role.
Yeah.
So.
Well, and I studied jiu-jitsu at the Gracie Academy. Do you guys know the Gracie family? You guys know out in Torrance, the Gracie family? If you study jiu-jitsu out there, you guys watch the UFC, but you may not know where it started. It started with them out in Torrance. You ever met people who focused every second of their life perfecting what they do? Do you guys know what that's like? This is what these guys do. Every second, we'd ask them, what'd you do this weekend? You know what they tell us? We came to the academy because it was closed for the weekend. and they practice the whole weekend standing on a, what is that, a Swiss ball, an exercise ball. The whole weekend standing on that ball trying to balance themselves because they had to work on muscles that, people don't use. Core muscles. They spent their whole weekend balancing themselves on the medicine ball. That's what they did for fun. Were they out at a club? Were they drinking? Were they chasing women? Were they gambling? Were they playing Xbox? No. They were focusing on everything that they could do to perfect what they do. They did it 24/7. Are there people like that in the world? Yeah. You guys know people like that? You ever ran into anybody like that? There's whole cultures that are like that. They spend every second perfecting what they do.
Practice makes perfect.
This is what I've been telling you guys. If you keep doing this, you're going to get better and better. That's the way you do it. There's no other way. So if you do meet people like that, you could recognize, oh, they have the formula down. They know how to do all of this. The secret. Spend your time every day working on perfecting what you do. And if you do, you're going to go farther than if you didn't. You'll go a lot farther. You might even major in math. And you never even considered it. There's no reason why you wouldn't. Here we go. You guys ready? Here's what you guys really have now. They're going to tell you to factor, but this time you're going to factor something that looks like this. 6x squared plus 15x minus 9. Now I'm leaving this up here for a good reason. Does anybody know when you try to factor this, what happens? Well, I don't know. What's your real procedure? They might say to you, factor, they'll use the word here, completely. Okay? They want to say, factor completely. What that means is, take out or factor out the greatest common factor first. Okay? So what you're going to do, if you can, each one of these you couldn't. What I'm going to say to you, first, factor out the greatest common factor. What is the greatest common factor of 6x squared, 15x, and 9? 3. Isn't that your greatest common factor? What is the quotient? 6x squared divided by 3 is what? 2x squared. 15x divided by 3 is what? 5x. 9 divided by 3 is what? Minus 3. So here's my quotient. Let me write it this way. You should have 3 times 2x squared plus 5x minus 3. Here's your greatest common factor. Here's the what? Here's the quotient. So what do you do now with that quotient? Here's what you guys do now. The second thing you'll do after you factor out that greatest common factor, let's leave it that way. You simply what? Factor. You factor the quotient. Now here's the good news. You already know what that was. What recipe do you think you'd have to use here when you try to factor out that quotient? It's a beef stew situation. Now, did you guys see, didn't you do this already?
Yeah.
Yes, you did. So this is how it works. Take out that greatest common factor first. Whatever's left as a quotient you factor happens to be a beef stew scenario. There's no way you can avoid that. It's beef stew. So, do you guys know what the final answer is? 3. Let's try this one here. Let's do 12x cubed minus 56x squared minus 20x. Okay, what recipe do you guys use here? You can't tell me it's beef stew even. You know why? That's x to the third. And this is enough to say it's not beef stew. So what do? Take out the what? Greatest common factor. You always do that first. Factor out your greatest common factor. Okay? So you want to factor out that greatest common factor. What do you guys have left if you do? 12, 56, and 20. What do you think? Is it 3? 3 doesn't go into 20, ladies and gentlemen. It's going to be 4. What's the variable? X to the third, x squared, x. Elisa, what do you think? X to the third, x squared, and x. Which one? Good. See how you know that? Did you eat any turkey, or did you just factor this Thanksgiving? You had some? Okay. She knows the greatest common factor for x. You imagine? What's the quotient? 12x cubed divided by 4x. Isn't that 3x squared? And then you got 56x squared divided by 4x. What's that? Minus what? Did you guys notice? Isn't that minus 14x? 20x divided by 4x, that's minus 5 because the sign's negative. This here, to point out to you, is your greatest common factor. Here's my quotient. What do you guys have to do to factor the quotient now? What recipe? Beef stew. Good. And now, what are you left with? 4x times, we did this already, beef stew, 3x plus 1 times x minus 5. You are done. There you guys go. Okay, they want you to do what? Factor completely, which for us is everything all the time. So let's see if you're really okay with this. 3x to the fourth power plus 4x cubed minus 15x squared. This is not, again, beef stew, because this is x to the fourth. So what's the first step you have to do? Factor out the greatest common factor. So your greatest common factor here is going to be what? Just x squared. Good. The quotient? 3x squared plus 4x minus what? 15. So here's my greatest common factor. Here's the what? Quotient. What recipe do you guys use to factor the quotient? Beef what? Beef stew. All right, here we go. Did we do this already as a warm-up? Sure did. So let's see the final answer. X squared times 3x minus 5 times x plus 3.
So you don't add in the x squared until you're completely done again, right?
Yeah.
You don't put it until you're done with the beef stew, right?
But you always, but I would suggest you guys always bring it down.
Bring it down.
Yeah, because you know what happens is students, like I said, the idea is to show you the factor completely strategy is really just your general factoring strategy. You always take out that greatest common factor. If it's 1, well then, there's nothing to take out. So in each case, you took out a greatest common factor. And then you always factor the quotient by your recipe, beef stew or chicken soup. Okay, so it might be beef stew, it might be chicken soup. In this case, it's beef stew. But you want to know the most common error that people make? They give this as an answer. They forgot to bring down the what? Greatest common factor. And it breaks my heart to take points off. That's like, oh, it's so close yet so what? Far. They did the whole process, they just forgot to put that greatest common factor. So I would recommend to you guys, like I said, how I used to study, like I told you, I might, in my notes, label this in red, greatest common factor. I might even on my homework, every problem, label it in red, greatest common factor. Because you know what I was really doing for myself? Training myself to go through that process and to not leave it behind. You see? And that's the difference. I mean, it's so close, yet people who can do this, and yet people who can't. It's just a close difference. It's a matter of how you trained yourself. See, if you ever played sports, you know, organized sports. I used to play organized sports. There's nothing special about me in any way. You know, really, there's nothing. Where did I grow up? No, that's the Beverly Hills of my neighborhood. Where did I grow up? You know what part of East LA I grew up in? No. Matavia. I tell you already? I grew up in the Matavia portion, sleeping on some floor with cold beans on the stove. And I no love for the beans. And sometimes my cousins would stay over, and I ask them, I see them brushing their teeth, getting ready for bed. I'm like, because we talked about this the other day. I said, you're staying over? Yeah. Where are you going to sleep? I had to get my spot right away. I'm going to bed now. I got to find my spot on the floor because they might have got the warmest spot.
What about the stuff in the fridge that you guys eat?
Oh, you guys know. This is true also. I say this, that if you ever go back and tell your family, like my mom would get mad at me. You know, because you know how moms are. They don't want you telling the truth. You know what I got so hungry. You know what I used to have to eat sometimes? Because there's nothing to eat? Chips. You know this already, Lisa? I used to go to the fridge and scrape the ice off the freezer. It wasn't always clean ice. It was dirty ice. I was hungry. I had to eat ice. Could you imagine? Dirty ice. I didn't know what carne asada was until I was an adult. Did you guys know that? So all I'm telling you guys is, what did I have to learn how to do? How to study and how to be successful. All I had was like sports. I played organized sports. So I learned, if you practice, you got better. I used to always get mad at the kids that never practiced. If we lost, it's because some kid didn't practice, you know, growing up. I used to get pissed off. So I always learned. And what did I learn how to do? If I don't want to forget that greatest common factor, I'm going to bring it down. I'm going to notate it in red. I'm going to practice. And that's the only recipe I have to tell you guys. There's no silver math spoon that people have where it's not genetics. Because nobody in my family took anything past, you know, maybe algebra, bless you. Nobody in my family got past algebra. It's not genetics. How about this? What if they tell you to factor completely? So what do you guys think? What's the process again? This is not beef stew or chicken soup. What do you have to do? Factor out the what? Factor out the greatest common factor. So what's the greatest common factor now? 2, what is it? 2xy, good. They're going to throw in some of those y's. I've seen that. And then now, what's your quotient? Divide here. What do you guys get? 6x squared plus what? 19x plus what? Plus 10. So here's the greatest common factor. And here's your what? Here's your quotient. What recipe do you guys have to use? Beef stew. Two xy. I'm going to label it. I'm going to bring down my greatest common factor. I don't want to forget that. I want every point possible on a test. So then now, we already factored this. And you got what? 2x plus 5, and you get what? 3x plus 2. Okay, anybody have any questions on that last one? Anybody have any questions on this one here?
So you break it down?
Yeah, I guess if you mean by factoring, break it down, yeah.
Yeah.
Bring down, yep, that's really what you're doing. You're breaking it all down. Okay? We're almost there. I'm going to make it easy for you guys. Let's factor, let's see if you're really awake. 2x squared plus 5xy minus 3y squared. You're going to factor. Tell me if you guys notice the difference here. 3x squared minus 14xy minus what? 5y squared. And then you got here again, factor 3x squared plus 4xy minus 15y squared. Didn't we talk about the symmetry idea?
Yes.
Good. Thank you. Do you guys notice what I'm saying here when I talk about symmetry? What am I saying? Do you guys remember that symmetry concept? What are we talking about? What's the difference between this problem and this problem? Yes, you see this? They added a y right in the middle. And then this is y squared over here. Do you guys remember that? Same thing here. See this? See what's new is you have this y and you got this y squared. Y squared. Y squared. So what would you really do? You would factor, ladies and gentlemen, 2x squared plus 5x minus 3. Remove the y's. Factor those. Factor, remove the y's. 3x squared minus 14x minus 5. Factor 3x squared plus 4x minus 15. Remove the y's like you guys did before when you had that kind of symmetry, meaning y to the first and then y squared. You're going backwards, but with y. Y to the first, y squared. X squared, x to the first. So it's going backwards, but with the variable y again. Remember how we factored this? We sure did. Where is it? It's right here. That's 2x minus 1, x plus 3. So this is what you do. Use your beef stew recipe. But that's not what we have. What do we really have here? The y's are there. So if you recall, what did we do? We'll write down 2x minus 1, x plus 3. What did we do when we had these y symmetries? Let's see if you remember. What did we do?
Well, we rewrote them at the end.
What am I looking for? What do we do? I'll put it in red. Put the y term back in, right? Meaning put what here? Put y back here for their last terms. Exactly. And you're done. So for each one of these, you're going to factor this. It's right here. I'll put the final answer. 3x plus 1 and what? X minus 5. Just toss your what? The y's. Same thing here. 3x minus 5. X plus 3. Plug your what in again here? Plug in the y's. Over here, this is going to be 2x plus 5, and what? 3x plus 2. Plug in your what? Your y's. So the symmetry concept is back. And what I want to now say to you guys is you should really be able to do now all of your what? Homework. You will also have this section over here. Remember, you guys can tutor my calculus class when you master factoring. All right, you guys okay with this?
So what covers our quiz on Monday?
The test?
What chapter?
I don't know, I gotta take a look. Gotta take a look at that. We gotta look,